Welcome viewers. In this video we'll see the relationship between two port network parameters, H parameter in terms of Z parameters. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, two port network parameter. There are four two port network parameters are available. First one is Z parameter, open circuit impedance parameter. This is Z parameter. And Y parameter, short circuit admittance parameter. Then H parameter, hybrid parameter, combination of Z and Y. Then ABCD parameter, transmission parameter. Designing of transmission line can be done with the ABCD parameters. So we have Z parameter, Y parameter, H parameter and ABCD parameter. So in this video we are going to express the hybrid parameter in terms of Z parameters. Now we'll see the general equation of a hybrid parameter. V1 equal to H11 I1 plus H12 into V2. I2 equal to H21 I1 plus H22 V2. This one refer input port, two refer the output port. So input port voltage and output port current are expressed in terms of input port current and output port voltage. So both voltage and current are mixed together. So that is called a hybrid parameter. In case of Z parameter, open circuit impedance parameter. This open circuit means either input port or output port is open circuited. V1 equal to Z11 I1 plus Z12 I2. V2 equal to Z21 I1 plus Z22 I2. Here voltage, input port and output port voltage are expressed in terms of input port and output port current. Voltages expressed in terms of current. Here both current and voltage is mixed together. That's why called a hybrid parameter. Now we'll see how to get the relation between H parameter and Z parameter. For that we are going to modify the equation 4. Now we are taking this H parameter equation as 1 and 2, Z parameter equations are 3 and 4. Now we are going to modify the equation 4. So this is the equation 4. V2 equal to Z21 I1 plus Z22 I2. So this term Z21 I1 we are going to brought left hand side, so that it become negative. V2 minus Z21 I1. This term is brought in left hand side. So this term as it is Z22 I2. Now it is rearranged. This term is written this side. These terms are written that side. So Z22 I2 equal to V2 minus Z21 I1. Next step we are going to brought this Z22 in the denominator. Right. So that I2 equal to, so I2 equal to 1 divided by Z22. This Z22 is brought in the denominator into V2. Z21 divided by Z22 into I1. This minus is there. Right. So this term is brought in the denominator. So we'll write this term first. I1 term we'll write. Then we'll write the V2 term. So that I2 equal to minus Z21 divided by Z22 into I1. This term. And this term is written here plus 1 divided by Z22 into V2. So I1 V2, right? So take this equation number 5. Now we got the, by modifying equation 4 we got equation 5 that will give the expression of I2. Now we are going to substitute this I2 in equation 3. We see what is equation 3. So this is the equation 3. V1 equal to Z11 I1 plus Z12 I2. In that we are going to substitute this I2 from this equation 5. Right. So this I2 is replaced by the equation. From equation 5 the I2 value is substituted. Now multiply this Z12 inside. This Z12 commonly available. So Z12 into Z21 divided by Z22. Negative is there. Right. Then Z1 is multiplied here. So Z12 divided by Z22 into V2. Right. So we have 3 terms. In that the first 2 terms I1 is commonly available. So we can take I1 outside. So this term I1 is taken outside. So what we got, Z11 minus Z12 into Z21 divided by Z22. This is V2 term. Now this Z22 is taken as common LCM. We are taking LCM, so that this term is multiplied here. Z11 into Z22 minus Z12 into Z21 divided by Z22. So this can be written as, this is nothing but determinant of the Z matrix. Z11 into Z22 minus Z12 Z21 is the delta mat, determinant of Z matrix. So that is written as del Z. So finally what we got, V1 equal to del Z divided by Z22 I1 plus Z12 divided by Z22 into V2. We'll take the equation number 6. So now we got the expression of V1, right? In the earlier case we got I2, now we got V1. So we rewrite the equation, we got equation 5 and 6. Now we are going to compare the equation 5 and 6 with the equation 1 and 2, so that we got the relationship. So what we got, equation 5 and 6 is available. This is equation 5, equation 6. Equation 5 gives the expression for I2. Equation 6 gives V1. So we already have equation 1 and 2. That is nothing but hybrid parameter equation. V1, I2. So here also V1 available, here also V1 available. So we can compare equation 6 and equation 1. Similarly, equation 2 and equation 5. There are I2. Right? So first we will compare equation 1 with equation 6. Equation 1 is V1, equation 6 also V1, so that we can compare. The coefficient of I1 is H11. Here also coefficient of I1 is del Z divided by Z22, so that we can write H11 equal to del Z divided by Z22. Similarly, coefficient of V2 is H12. Here coefficient of V2 is Z12 divided by Z22, so we can write H12 equal to Z12 divided by Z22. Now we can compare equation 2 and 5. Coefficient of I1 is H21. Here coefficient of I1 is minus Z21 divided by Z22. So that is written here, H21. Similarly, the coefficient of V2 is H22. Here coefficient of V2 is 1 divided by Z22. So that is written here, 1 divided by Z. Now we got the relationship of, that is H parameter expressed in terms of Z parameter, right? So this H11 is equal to this value, H12 is equal to this value, H21 is equal to this value, H22 is equal to this value. So that by comparing the coefficient we got the relation between H parameter and Z parameter, because both the equations are similar, V1 and I2. Here also V1 and I2. So in this video we discussed how to get the relation between H parameter and Z parameter. Initially we discussed what are the two-port network parameters are available, then what are the general equation. By reframing the equation we got equation 5 and 6, that is compared with equation 1 and 2, so that we got the relationship. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.